Okay, so this bit is going to be about the radiation, or the parts of the EM spectrum that heat things up. Now, we looked last time at ionising radiation, and we said that these three were ionising, so UV, X-rays and gamma rays are ionising radiation. Today we're going to focus mainly on these two, which microwaves and infrared, and these heat things up. So this is heating radiation. It's not really called heating radiation in general, but that's what the effect is. Now, this is because they've got less energy than ionising radiation, and that's because they've got a longer wavelength. Now remember, ionising radiation is something that knocks an electron out of a shell, electrons out of an atom. So they've got to have lots of energy to do that, knocks electrons out of an atom. They've got to have loads of energy to be able to do that. Microwaves and infrared have got less energy, and they don't have enough energy, not enough to do that. Okay, they don't have enough energy to do that, so they do something else instead. So if I send a heating type of radiation, so maybe a microwave, towards a material, here we go, what happens is it has energy, so it causes these atoms in the material, these are all atoms, to jiggle about, okay? It causes them to vibrate up and down, side to side, all different directions. So it causes them to vibrate. Now, something that vibrates, when atoms vibrate, more vibration in atoms means that they are hotter. So making an atom vibrate heats it up. If you do that to lots and lots of atoms in a material, that material is going to be heated up overall. So it doesn't have enough energy to knock the electrons out of the shells, but it does have enough energy to make that atom vibrate, and that heats it up. So that's how they work in basic principle, UV, not UV, IR and microwave. So IR means infrared. Microwaves do this by making the atoms vibrate and heat up. Now, the most obvious use of heating things that we can think about, because of the word, is a microwave. So in the kitchen, you've got a microwave, and they work obviously using microwaves. That's why they're called that. Now, microwaves are reflected from metal, and that's why you can never put metal in the microwave, because if you've done it, I've done it once with a yogurt pot by mistake, and it started to blow up. And also absorbed by water and fat. Now what happens is that here, this little plot here, this produces microwaves. Now the microwaves travel and they bounce around the microwave, because the inside of a microwave has actually got a kind of metal lining. We'll talk about that more in a second. They bounce around, they're reflected until they go into the food, okay? Now the food has got to have some water in it, or some fat. Otherwise, it won't heat up. If you ever put a dry biscuit in a microwave, you'll see that it doesn't really do much. It doesn't heat very much at all. Now, the water or the fat in the food absorbs the microwaves and starts to vibrate more. So the water fat vibrates more, and that heats it up. So if you've got food with lots of water in, especially things like soup, which is mainly liquid, they heat up really well. Now, you have to use the turn plate, you have to keep turning it around, because we set up some kind of standing waves, which you don't really need to know about, but the microwaves kind of concentrate in certain points, like here, here and here. Now, if you took out the turning plate and just put, say, a piece of cheese on toast, is really good to do this on the bottom of the microwave, and didn't let it turned it on, you'd see on the toast later on, you'd get a pattern of bits where where the cheese had melted, and it wouldn't have melted anywhere else, because those microwaves just go to one certain place. Now, at the front of a microwave, on the door, you might not be able to see it, but it has a really, really fine metal grid. Now, you can see through it because you want to be able to see your food. This metal grid stops microwaves coming out. Stops microwaves getting out of the microwave. And this is for your safety, because people aren't completely sure yet if microwaves are safe. You may have heard of some of the problems, or some of the theories that microwaves in mobile phones cause cancer. Now, they're very, very, loose. Like, we're not really sure if it's true or not. We don't think it is, but we're still not completely sure. And we want to be better safe than sorry, because also microwaves, humans are made of 70% water and a lot of fat, so they could cook in a microwave quite easily. So we need to be careful and, make sure that we protect ourselves. So microwaves work by making the water and the fat in food vibrate, and that makes them heat up. And the metal grid is there to stop you from being microwaved yourself. Now, there's two ways that we can increase how quickly the food heats up, and that is by increasing the intensity. And we talked about that, and that's what the power dial does. So when you turn up your power dial, or we can increase the time the microwave is on for, and that's what your timer is for. Okay, so that's how you control how much microwaves will heat up the food, and that's why it works. There's another thing to think about. We talked about microwaves there. We need to think about infrared. Now, infrared radiation, IR, is also known as heat. Okay, so when you can feel heat but you can't see anything, that's infrared. So when you can feel heat from a toaster, you can see that it glows red, and that's why it's towards the red end of the spectrum. But you can't see the heat. You can feel the heat though, and that is infrared. Now, different things glow at different colours. If you looked at yourself under an infrared camera, you'd see that your heart and your core regions were much, much warmer than, say, your feet, and they'd be a different colour. If you have a look at an infrared picture, I've got one here actually, in the textbook. So here's an infrared picture of a dog, and you can see that animals are too cold to emit visible light, but a special camera can detect the infrared radiation they give out. So the warmest part of the dog, so the chest and the head, is red. The colder parts, like the ears, is blue. So it's just the way the camera works. So we can see that they've got a different temperature, and the surroundings are even colder again. So they're really blue, they're really dark. Now, colour is dependent on heat. Okay, so the hotter something is, the different colour it appears to be. And this is really easy to see when we think about Bunsen burner flames. So when you put your Bunsen burner on the safety flame, it's the coolest flame, and we see that it's a kind of a yellowy orange colour. Yeah? So it's this kind of colour here. Now, if we then turned it up so it was on the heating flame, it would go to blue, maybe with a bit of purple in the middle. Okay, so I'm just going to do this way. A bit of purple in the middle. Now, if we could theoretically turn it up more, it would be more purple, and you'd also get around it, you wouldn't be able to see this, UV radiation. Now, this isn't really possible, but if you could heat it up more, if I draw a line here, and this is increasing heat, we get UV radiation. And then the hottest things in the universe give out X-rays and gamma rays. Okay? Now, if we go down the other way, so this way, you'd get a red flame, and then you'd get around it infrared. Now, you can't see infrared, but infrared is how things like toasters, this is an important thing to know, toasters and grills work via infrared. You may have done, in a few years back, conduction, convection, and radiation. When they say about heat being carried by radiation, they mean infrared radiation. And once again, theoretically, if you could get colder than that, you'd get microwaves, and then eventually radio waves. So the cooler the object is, the lower on the spectrum the colour or the radiation it emits. So starting with radio waves, then you get cool things like humans emit infrared. A bit hotter, still emits infrared, but a bit of red. So a grill has infrared and red light. Then a fire is yellow. A really hot fire, so like your Bunsen burner flame, is blue and purple. And then theoretically, things like supernova emit UV radiation and X-rays because they're really, really hot. So it's important to know that the higher up you go, increasing heat, increasing energy, you go up towards the gamma ray spectrum because there's more energy over there. So that's a quick thing about radiation and how it heats things up. You don't need to know too much about it, just that it makes particles jiggle, and that heats them up. And the main ones that do it are microwaves, which you know obviously are used for in a microwave, and also infrared, and they're used for things like toasters and grills. Excellent. Hope that's helpful.